My name is Nahida Sultana from Group 7. Today we will be presenting our research on green manufacturing, digital waste management in the UK automotive sector. This presentation was prepared for essential of artificial intelligence in business and digital management, and we choose this topic because the intersection of digital technology and environmental sustainability is one of the most critical challenges facing modern industry today. Before we dive into the details, here is our team members, Aki, Shirin, and Tega, and me. We have worked collaboratively to analyze how digital transformation can drive more sustainable outcomes in vehicle manufacturing. And content, we will begin actually with the introduction and organizational context, followed by a detailed case study on vehicle manufacturing in the UK, and finally, we will address the ethical, legal, and societal implications, provide evidence of our collaborative process, and conclude with our group reflections. Now, let's to the point. Currently, the industry is a major contributor to industrial waste. However, we are seeing a massive shift, increasing environmental regulations and global sustainability targets are forcing a move toward more efficient practices. The game changer here is the integration of Industry 4 technologies like IoT, AI, and cloud platforms are no longer optional. They are become the backbone of modern factory operations. If we see our problem statement, why is this actually change is necessary? Because traditional waste management methods are falling. They are often manual, reactive, and slow. This leads to unnecessary cost, excessive landfill use, and missed opportunities for recycling. In a competitive global market, these inefficiencies are no longer sustainable. Look at our objective. This brings us to our core objective for this study to explore exactly how digital technologies can transform waste management and recycling within this sector to create a more circular and profitable manufacturing model. Now, next case study. Now let's look at how these concepts are being applied on the ground through our case study of the UK automotive sector. As you can see on the left, production lines are being redesigned around the circular economy principle. This is not just about being green, it's about responding to legal pressures like the end of life vehicles directive, which mandates that manufacturers take more responsibility for their products at the end of their life cycle. And look, see our current status. The industry has already made impressive strides. Currently, over 95% of a vehicle's weight is recyclable. Most steering facilities in the UK are now targeting zero waste to landfill, meaning every scrap of metal, plastic, or glass is diverted back into the supply chain. To achieve this three key strategies are in play: material efficiency, material recovery, and EV future proofing. Ultimately, the core mission is to use data-driven tools to ensure that waste is seen as a resource rather than a burden. On that note, I will hand over to Ria, who will dive deeper into the specific digital tools making this possible. Thank you.
Thank you, Nahida. I am Shireen Sultana. I will explain the key digital technologies that are transforming waste management practices within the UK automotive manufacturing sector. ERP, MES, and data analytics systems integrate waste measurement data with production and procurement information. Manufacturers can identify waste hotspots across different stages of production, monitor material losses in real time, and implement data-driven process improvements. IoT and smart bins enables real-time monitoring of waste conditions. Sensors embedded in bins track fill levels, temperature, and contamination. Big data analytics help to gain actionable insights into waste generation patterns, recycling rates, and operational performance. RFID and digital waste tracking systems provide end-to-end traceability. RFID tags allow waste to be tracked from its source through transportation to final disposal. Automation and robotics significantly improve efficiency within waste handling operations. Automated conveyor belts, compactors, and robotic arms increases the throughput. Route optimization and fleet management systems use GPS-enabled software to dynamically plan the most efficient waste collection routes. Next slide. This slide highlights the key operational challenges in implementing digital waste management. And the complexity of non-metallic waste recycling, such as plastic and composite materials, makes efficient separation difficult and threatens the achievement of the 95% end-of-life vehicle recovery target. And there is a lack of expertise in new waste streams, particularly electric vehicle batteries. This limits manufacturers' ability to repair and recycle battery components such as EV adoption increases. The absence of unified data standards restricts digital integration. Waste management systems depend on reliable data, but inconsistent data sharing reduces interoperability across the supply chain. Regulatory gaps and high voltage battery circularity challenges add further complexity. Unclear guidance on battery handling combined with high repair costs and limited design for repair makes full circularity difficult to achieve. Now I would like to invite Tega to continue the rest.
Thank you very much, Ria. This slide explains the impact of digitalization on waste management. Digitalization has significantly improved waste management in the UK automotive sector by making processes more efficient, more accurate, and also sustainable. There are four key impacts which affect this impact of digitalization on waste management. Number one, improved waste management tracking and traceability through digital tools, helping manufacturers monitor waste streams in real time. Also, higher recycling and recovery rates, especially for complex waste such as EV, batteries, and non-metallic materials. Also, cost reduction and operational efficiency by minimizing manual and manual processes and reducing landfill dependency. The last point explains better compliances with environmental regulations, supporting green manufacturing and circular economic goals. The overall explanation is direction enables smarter decision making, which reduces environmental impact and supports automotive move towards zero waste to landfill. Slide 9, please. Thank you. Slide 9 explains the ethical, legal, and societal implications. The adoption of digital and society and AI technologies also raises important ethical, legal, societal considerations. However, I'll giving breakdown of these three functionalities. Under ethical implications, AI decision making raises concern around safety and accountability and moral responsibility. Also, data privacy risk arises from connected vehicles collecting, processing personal data. Lastly, we have the potential algorithm bias may affect driver's assistance system and also decision making. We also have the legal implications. Under legal implications, we have the unclear liabilities in accidents involving autonomous vehicles. We also have mandatory compliance with the Data Protection Act in 2018. We also have the regulation under the Automated and Electric Vehicles Act in 2018. Lastly, under legal implications, there are growing needs for strong cybersecurity standards. In conclusion, under societal implications, job placement due to automation in manufacturing operations improve mobility and accessibility, especially for elderly and disabled users. However, public trust remains a key barrier alongside concern about batteries and sustainability. At this point, I would like to forward the last slide to my colleague Aki to continue.
Thank you, Tega. Um, Hi, I'm Akhi Akhtar. Now I'm going to talk about my topic. So showing the examiners that the group used as a logical process to arrive at their findings, moving into the evidence of our work. Our team didn't just collect data, we applied a structured approach to ensure our insights were deep and accurate. Firstly, we developed a step-by-step methodology to especially analyze how digitalization directly impacts on both waste management and overall factory performance. We didn't rely on a single source. We drew meaningful conclusion by synthesizing information from multiple industry reports and academic sources. Crucially, this was a collective effort. We reviewed and refined our findings as a group to ensure that the final presentation you see today is clear, accurate, and highly professional. And then conclusion, summarize the key findings of Enter research project. To conclude our research on the UK automotive sector, we have identified the five critical takeaways. Uh, Digital traceability is no longer optional. It is now essential for managing complex components like EV batteries safely. As smart systems work, we found they deliver measurable benefits in both reducing cost and lowering carbon dioxide emissions. And AI-driven sorting is the key to handling complex waste streams that traditional methods simply can't process efficiently. Finally, technology is only half the battle. Workforce skilling is a criteria to ensure that employees can actually operate this new digital system. And then group reflection. Provide a behind the screens look at the team, learned how they overcome challenges. Reflecting on our project as a group, we have categorized our experience into four areas to focus technical and conceptual knowledge gain. To wrap our findings, let's reflect on our journey. We gained deep insights into how AI, lot, and data analytics are not just buzzwords, but practical tools that improve waste tracking and resource optimizations. We also recognize the critical role of our of circular economy principles in reducing the environmental footprint of automotive production. Finally, we now have a much clearer understanding of how AI transform complex factory operations into more streamlined, sustainable processes. Now, I would like to deliver the my slides next presenter to present rest of the part. Thank you.
Thank you, Aki. So, among our group reflection, we discussed the technical challenges of ensuring accurate and data collection across massive complex manufacturing and recycle streams. Furthermore, we addressed the ethical concerns, specifically on how organizations can avoid greenwashing to ensure sustainability and authentic transparency. I would like to pass it on to my colleague Sultana for her to continue.
And thank you, Tega. Now I just will say our takeaway. What is our takeaway? Actually, what is the ultimate SWOT of the presentation? Looking at the bigger picture, on our main takeaway is that digital systems allow on reactive disposal to predictive waste reduction. We found that AI-driven analytics are the key to better decision making when it actually recycling and supply chain sustainability. However, technology alone is not enough. Successful implementation requires strong governance with a strict alignment with UK governmental policies. Now, Ria will take over the remaining part.
Our success of this project was about how we work together. Whenever we encountered research conflicts, we did not let them fester. We brought them into the open, and the honest dialogue was essential in quickly resolving these interpretation differences. Using platforms like docs, slides, and regular structured meetings allowed us to seamlessly coordinate our work. Every challenge we faced became an opportunity to see how different skill sets and perspectives contributed to a stronger and more creative solution. Next. Here are the references that we used in our case study. Thank you everyone for your time and attention.